numbers should match up, okay, in every single term. Okay, so now we just plug in. So f of 0 is just 0. F prime of 0 is 1. F double prime of 0 is 0. F triple prime of 0 is negative 1. And so I keep going since I found a fourth and fifth derivative, and I know the pattern now. I'm just going to plug in the derivative 0 over 4 factorial times x to the 4th. And same thing with the fifth derivative. I plug in 1 over 5 factorial times x to the 5th. Questions? Okay, so now I have 0, so that just goes away. I have x over 1 factorial. I'm not going to simplify factorials because I need to find a pattern in step 4, right? So I'm not going to simplify factorials because it'll be easier to find the pattern when I don't simplify them or evaluate them, okay? So the next term goes away because it's just 0. And the next term I have minus x to the 3rd over 3 factorial. And then I have 0 for the next term, that goes away. And then the next term is x to the 5th over 5 factorial. Minus dot dot dot. Questions so far? Okay, so now I want to express this in summation notation. So this is a Taylor series for sine x. However, I want to express it in summation notation, and I want to sum from n equals 0 to infinity. And so now I need to find the pattern. Okay, so what's one thing about the pattern? Someone tell me? Alternating. It's alternating signs. So again, I have negative 1 to the n. Something else. Right, odd powers of x, so x raised to an odd exponent. And how would I express an odd number? Alex?
2n plus 1.
Okay, 2n plus 1. So like x to the 2n plus 1. So why not 2n minus 1?
Then that 0 would be negative 1.
Okay, good. So we choose 2n plus 1 because 2n is even, right? An even integer is divisible by 2, so by definition, 2n is even. So I can either add 1 or subtract 1, and I'll still get an odd number. If I do 2n minus 1, let's just do that for a second. Okay? I plug in n equals 0, and I get x to the negative 1, but my first term here is x to the positive 1. Okay, so we know that it's not minus 1. It has to be plus 1. And now when I plug in n equals 0, I get x to the positive 1, so that matches up. Okay, so always check by plugging in the first term and see. Okay, and what else?
2n plus 1 factorial.
Right, it's 2n plus 1 factorial because the exponent, okay, matches the factorial. They're the same number. So 2n plus 1 factorial. Okay? So here we have odd exponents and factorials. So we express as 2n plus 1, since 2n plus 1 is always odd. And in parentheses are since 2n is even. Any questions? So now let's do cosine. So now we're going to find the Maclaurin series of cosine. Okay, so we can repeat the same thing. We can find the derivative, evaluate at center, plug in and find a pattern. However, that might take a little bit long. Okay, so you can check that on your own. Okay, instead, what we know is that the derivative sign is cosine, so why don't we just take the derivative of the series and then we'll get the series for cosine. Okay, so again, this needs to be memorized, just like e to the x. Okay, so that's another one that needs to be memorized. So right now, I'm just going to say sine x equals sum from n equals 0 to infinity, negative 1 to the n, is x to the 2n plus 1 over 2n plus 1 factorial. Okay, and so yesterday we took derivatives by taking the derivative of that pattern. However, I'm going to do things a little bit differently today. I'm first going to write out this series term by term, and then take the derivative term by term. Okay, so I plug in n equals 0 and find what that value is. So I have x to the 1, or 1 factorial. Okay, then I plug in n equals 1, and I have x minus x to the 3 over 3 factorial. Then I plug in n equals 2, and I have plus x to the 5th over 5 factorial, and so on. Okay, and so that matches up with what we had before, which it should before we found the pattern. Okay, so again, you need to memorize that sine x equals this series. Okay, and it also will be helpful to memorize the first few terms. Okay, so you can easily just plug in the first few values of n and then figure out from there. However, if you memorize it, that will save you a lot of time on an exam. Okay, so you do need to know this way also. So know both types. Okay, so now I'm going to differentiate each side. So I take the derivative of the left side, which is cosine x. And now I'm going to differentiate term by term. So the derivative of x is just 1. Then I take the derivative of negative x to the 3rd over 3 factorial. Well, 3 factorial is just constant. Okay, it's just some number. So I have minus 3x squared. And then I have plus 5x to the 4th over 5 factorial, and so on. What's 3 over 3 factorial?
X squared, 2 factorial.
Right, so that can just cancel out to 2 factorial, okay? Because we're going to do the same thing when we did ratio test. 3 factorial is the same thing as 3 times 2 factorial. So those 3's will cancel. Here, 5 factorial is the same thing as 5 times 4 factorial, so those 5's will cancel. So now let's simplify that. We have 1 minus, the 3's cancel, I have x squared over 2 factorial. Okay, and then we have plus x to the 4th over 4 factorial minus, so on. And so now we have the Taylor series for cosine x, okay, term by term. And again, you have to memorize that also, but now we want to express it in summation notation. Okay. So I have the sum from n equals 0 to infinity. Help me find the pattern here. What's one thing we notice? Right, it's alternating signs, so I have negative 1 to the n. Good, x to the 2n because the exponents and the factorials are even. And so if it's even, we can express it as 2n, because 2n will always be even, is divisible by 2.